Hi, and welcome to this demo video about the Eurostack Transducer system. So this little accessory is something I've been playing with for quite a while. As people know, I'm really interested in electromagnetism, and as well as that, the idea of kind of taking sounds outside of the Eurorack system to process them in the physical world. Very interesting for textures. So what is a transducer? Basically, it's a speaker. It's a speaker without a cone. So not to bore you too much, but a long time ago I used to be a science tech at secondary and colleges. I would set up experiments to help students kind of understand the curriculum, and something I would always push to do because it interested me as well, but also because it's a great way of learning about science. Science can sometimes be a bit arid, but when we can feel it and experience it, I think we can start to understand it on a more intuitive level. So I would set up these experiments with signal generators and transducers, solenoids, actuators, and piezos and things like that, so that students could feel and hear the things that they were being taught about. So yeah, it's essentially a way of turning anything into a speaker. Now the accessory is designed to be used with, it's originally intended to be used with this Eurostack Transducer. This is like a 1 watt amplifier in a small 6 HP module, and yeah, I added a DC 2.1 millimeter kind of your standard plug socket to the front. And what this means is, as well as using the built-in speaker, by plugging a cable into it, you're able to send the current out to another speaker. But then I started experimenting with and remembering my days playing around with transducers, and that's when things got kind of interesting. So yeah, it's a way of turning anything into a speaker. I'm going to set up some demos and show how I'm using it, with my system, I guess. Something people might have seen recently is I've been experimenting with DIY plate reverbs, and this. So there'll be a video, as we're in it at the moment, about the transducer. Another one about the piezos. And then there's going to be a third video about kind of bringing that all together and how we can send signals from our Eurorack system to the transducer and then process them by passing them through a physical material and then listen to them afterwards. And depending on what we pass the sound through, it will start to take some of the characteristics and tones of that material, which can be really interesting. I love the mutable instruments elements. It's a great physical modelling module. But as I always say with stuff like this, analog electronics is just that. It's an analog of the real world. It can never be the real thing. Something special happens, and just like words, when we name something, it's kind of lost in translation. Between what I say and what you hear and the way you interpret it, there's a lot lost. And the same thing happens in analog electronics. Essentially it's still just a model of the world around us. So by using things like transducers and piezos, I think it really takes us back to enjoying sound in I hate to say it, a more organic way. But anyway, here we go. Peace out.
On the line, as we value your call.
Okay, so here's the Beepboop demo system, and we are several hours away from that rather rambly introduction. I got completely distracted in the most wonderful of ways. To begin with, I just got out a load of different materials, things like wood, some metal, a teapot, which is porcelain, I think, I don't know, something that rattles, some plastic, although I don't really like it, drum, stringed instrument, and I was passing waveforms through them, just to see how they would change the tone, and it was all, kind of interesting. But let's come back to, the beginning, and just explain, how we would set this up. So the transducer itself has this base plate on, and it's actually possible, if you just give me a moment, to detach that. Here we are. And then you've got an M4 screw, in the bottom. So something we'll see later on, in later videos, is how we can attach this to a material, properly and permanently, with a M4 bolts and some M4 nuts. But for now, we're just going to go with the plate and use that to resonate different materials. So if anyone's not seen or heard the Eurostack before, it's a 1 watt amplifier in Eurorack format with I think it's 3 watt. So, there's a bit of room for manoeuvre. We're not pushing things to the very, very limit. And if you haven't heard this speaker before, I mean, it's pretty decent for... We're listening to all of this through an AKG P120, and we've got a waves and drops filter. It's like a Juno-esque kind of creamy filter normally, but we're just self-resonating it, so we've got an oscillator. So yeah, there's loads of room, and you can hear probably there towards the top end we start to get some kind of overdrive tone. Now this transducer is capable of taking much more power than these smaller speakers. As people might know with speakers, bigger speakers kind of have a better frequency response. I guess it's just a very basic way of talking about these things. So this thing is capable of taking, it says on the data sheet, I think up to 30 watts, which is pretty significant. I might do some videos later on, of how you can use this without a Eurorack system. For anyone who's ever fitted a DIY kind of sound system into a car, you can get these quite cheap amplifiers. That might be something for later on. But what I'm trying to say really is that this transducer is well over spec'd for this amplifier, but that's a good thing. It means that this is capable of kind of covering a wide range of frequencies. So we've got our cable, which comes with either the transducer or if you get the combo of the two. It's a 3 meter DC style cable, 2.1 millimeter barrel jack, and that'll go from the Eurostack into the transducer, and then we're going to hear it now just on the desk. And as we push it further up, of course it's going to start jumping and rattling around, but at the lower settings, yeah, so that's it, just going through a nice oak shelf, which I made from reclaimed floorboards, and we've got a bigger, thicker piece of wood here. So generally what will happen with wood is it'll have a bit of a deadening effect. It doesn't really resonate. If we put this on something metal, for example, this teapot, hopefully that's in shot. Now that's really going to start jumping around because this isn't fixed. But then it means you can start to play the teapot. We could get something else, maybe something that rattles. And there you go. Start. We could take some metal that does have a resonant frequency, like a singing bowl. This might be a little bit harder to do because you can see it's jumping around. Oh yeah, I got this earlier. Just something to put it in, so it'll... There you go. Maybe we put it inside it. I think it's taking more of the tone of the cardboard now. But you see my point. We can pass sounds through the material, and at the moment we're picking it up with the microphone, but we could AMSR style, listen to these materials at a different level. I like to think of kind of this idea of macro sound and micro sound, and just in the same way, let's say we set up this microphone and I turned my speaker monitors on, we would have macro feedback. It's going to blow out and start self-oscillating. You can kind of do this on a micro scale as well, which if we drove this very, very lightly and then had a contact mic, we would be able to make a material resonate. But that's for later on, other videos. I think I'm getting a bit ahead of myself. So that's with a sine wave, and maybe let's just try some different waveforms. Well, kind of like that. Yeah. Oh, here's something that might be a bit different. It's just plastic. Which seems to be taking a bit more of the high frequencies out. Okay, so at the moment we're not using... Maybe if you wanted to hear a bit more of the sound of the material, we could pass it through a VCA first, and just have little... Maybe I could do it... Let's have a think. Maybe this will work. Let's take a little bit of that sound and just control when we want it to go through. We're using the velocity out, so it's like a momentary out. So it's got a bit of decay. Yeah, let's try the teapot. let's try it in the rattly bin. I've got to be careful because it's going to pick up all of those, of course. This is magnetic, so, you know, keep it away from metal filings. You know, you could clean it off with, you know, what am I trying to say? Compressed air, if you did mess it up a bit. But, you know, let's try. That's great. Maybe overdriving a bit too much there. Yeah. So yeah, really cool. I'm quite happy with that. As well as passing. Yeah, let's do it. Why not? This might be kind of interesting. So the U-tape scrubber by default passes audio. So if we set this up in the same way, and we'll get rid of the VCA. So the sound's going through there, and let's get the U-tape scrubber going. I think I had a just to show it doing its thing there. So yeah, you know, we can make a weird collage of sounds and pass that through. Right, what was I doing? Ah, yeah, of course. So now that this was the thing that got me really distracted earlier. You know, I've been using this a lot as a way of just turning things, you know, passing sounds through them. But what about if instead of that, we actually just used it a bit like a solenoid? People might know I make a solenoid module called Magnetic Strike, and that works great. But, you know, this will do something a little bit similar. And I set up something a bit earlier. So let's put a... There we go. So we can just excite a material. Oh, I should move that. Sorry, I didn't realise this wasn't on screen. Give me a second. There we go. And I was having a lot of fun, you know, chaotic kind of behaviour doing this. Then I was trying, I'm going to move the camera, no, let's just push this forwards a bit. And then I was trying, these are two semitone apart. So then I was trying, and I could kind of play them in that way. I was making kick drums out of a kettle. I mean, that just sounds sick. And that's just, instead of a, I mean, I don't think it'll really, we just want clicks basically. So that's a ramping wave. Sounds good as a kick on the kettle. Over here we've got it's a little bit hard to tell with that, but yeah, you get my point. So we can use this to excite a material by sending you know, clicks and, you know, triggers and gates. So I think I'm going to leave it there because I'm getting a bit distracted. But yeah, I hope people kind of found this interesting. And if you would like one, head over to my website where you can either grab one of these for they're £65 and you get the cable, or you can get the combo with the speaker module and save yourself a tenner, and that's 120 altogether. So until next time, peace, love and electromagnetism. But yeah, get experimenting, and the next video is going to be about piezos and using it with the 2HP contact module. So I think I might do that kind of with this setup. We'll listen to some of the AMSR sounds, and like I say, this difference between macro sounds and, you know, the smaller, more invisible world. So yeah, thanks for checking this out now, and if you've got any questions, just leave them below. Bye. So I set my demo system. So I set my. Oh, whoops.